Hello, my name is Jarlin Pineda and this is my lab presentation of the plate tectonics for NATS 1020. I first want to start off with probably my convergent subduction boundary. This one was pretty easy as it was just really sliding one into the other. And for mine, I had to actually use crackers because I didn't have the Graham crackers. So I had decided to just use these, and it actually worked pretty similar from like the video presentation. Like, I really like how it turned out. It was a little messy though. And then from there, this was the first example of the divergent boundary. This one was really cool and like easy too. It was just, you know, separating the two and then seeing the cream just rise to the top. And then the transform boundary. This one was cool, but it took a while for me to see like that example of how like when the tectonic plates are like kind of like rubbing against each other, like how I wanted to simulate like that violent like set of movements that they have with like the crackers, so like that crisp falling off and whatnot. And like, yeah, so I was just doing that same motion, rubbing them back and forth horizontally to see like how it progresses over time, and it would do that. So it was cool. And then this is my favorite one because it actually worked. It like built the crackers to the very top. This is the continental collision. And this one was really cool, but it was so hard to do properly because I think since I didn't have the right crackers, I couldn't do it with them being dry. But I know in the video it showed them being dropped into water, which I did. And so I dropped it into water and I soaked them in probably for about like 20 seconds because since these are different crackers, they weren't meshing right at first. They would still stay pretty solid. So I found that right consistency, and then that's when I collided the two, and it simulated like those mountain ranges that you would get. And it's really cool. I really like this one a lot. But yeah, this is my presentation.